Friends, today I'm going to solve LeetCode problem number 2300, successful pairs of spells and potions. In this problem, we are given two integer array spells and potions, each of length m and n, and we are also given an integer success, and we need to return the pairs of spells and potions, each spell and potion where the product of the spell and potion is greater than or equals to success. Let's look at this example. So we are given an example here. The value of success is equals to 7. Now we need to find two pairs. One value would be from spells array, the another value would be from potions array. So we take the first value from spells and potions. Now we take the product of those values. So 5 times 1 is equals to 1, and 5 times 1 is equals to 5, and we know that 5 is less than 7, so we basically cannot count this pair as a successful pair. So next what we take is we take the value 2 from the potions, and 5 times 2 is equals to 10, and we know that success is 7, so 10 is greater than 7. So now our count of successful pairs is equals to 1. Similarly, we do it with the rest of the elements, and here we find that the number of pairs for this spell 5 is equals to 4, right? Similarly, for 1 we do it in the same way. So this is a brute force for solution. So for 1 we start from the first element, and we know that it's less than 7, so 1 times 2, 1 times 3 is equals to 3, is less than 7, so none of them would now be successful, so that would be equals to 0. And then next we take it for 3, and then we know 3 times 1 is equals to 3, 3 times 2 is equals to 6, still less than 7, 3 times 3 is equals to 9, greater than 7, right? So then now our count of spell is equals to 1, 3 times 4 is also greater than 7, so now our count increases by 1, and 3 times 5 is also greater than 7, so now our count is equals to 3, right? So this is the array that we need to return. Now if we solve this problem in this way, that is the brute force method, that is we take each of the elements and we iterate each of them, and for each of the element we are starting from the first and we are iterating one by one, right? So that would be a time complexity of n times m if the size of spells is equals to n and the size of potion is equals to m. So how can we optimize this solution? One thing to keep in mind is that our resulting array should be corresponding, each element in the resulting array should correspond to the respective element at that index in the spells array, in our original spells array. So basically we need to keep the indices, right, intact. That is, we cannot change the index. So we can change here, right? Potions, the index of the potions doesn't matter. So what are we going to do is we are going to use binary search for this solution. So binary search in a way that, okay, so what we're gonna do is we have the spell equals to 5 and we have the success equals to 7, and we know that the value of spell times the value of potion should be greater than or equals to 7. That would mean that the potion value should be greater than equals to 7 divided by 5, right? So we need the value of potion that is greater than or equals to 7 divided by 5. So what we can do is we can sort this potion. We are lucky that this array is already sorted, but if in case it were not sorted, we would sort this potions array, and then we will look for the value of potion, that is the value of p in this array, and we will keep on looking until and unless we don't find the value that is equals to greater than or equals to p, and once we find a value which is less than p, that is when we take the value at that like index at index +1. Like basically here, let's look at this. So the value would be here equals to 1 point some value, right? So that means that we need the value of p greater than 1 point some decimal values. So what are we gonna do is here now we are going to perform a binary search. So since this array is already sorted, I'm just going to perform that search here. So our left index is this, right index is at the end. Now this becomes our mid value, and we know mid is greater than p, but is it still the number of like portions? 2 is still greater, right? So what are we going to do is, as long as we find the value of m greater than or equals greater than the value of p, we will keep on going towards the right. Greater than or equals to, as long as it is greater than or equals to p. And then now we go towards the right. So now our right left, and then our right now becomes equals to 2. Now the mid here becomes equals to the value at our index left. So mid and left are pointing to the same value. Now what happens here is mid is less than the value of p, right? The value of p, which is 1 point something. So since it is less, what we do is we take the value of, we increase the value of left now. So now left becomes equals to m+1. So now our new left is equals to this index, and our mid will also be the same index. Now since both left, right and mid are equal, what we'll do is we would break out of our loop, and then that left index would be our value. So this index would be our value, and that is how we know that index. And once we find this index, we could just take the length of these portions, which is equals to 5, and the index here is equals to 1, right? So we would subtract -1, and then we would get the value 4. So for 5, we know the result is equals to 4, right? And that is how we are going to do with the rest of the elements in the spells array. So for this solution, we are going to perform binary search. Now let's try to code our solution. So first of all, let us define m equals to spells.length and n equals to portions.length. All right. Now let us create our binary search function. We will need the left, the right, and the target, right? Now while left is less than equals to right, what are we going to do is we are going to find our mid. So let mid equals to math.floor value of left plus right divide by 2. Once we have that mid, we are going to make our comparison if portions at index m is less than our value, our target value, then we will do left equals to mid +1, else we are going to do right equals to mid -1. And then finally, once the loop breaks, we are going to return the left index. Now that we have performed our binary search, let's try to now find, okay, let's iterate over each of the element in our spells array. So spell of spells, for each of the spell we need to find the portion, right? So the portion, let's denote it by p, and that would be equals to success divided by the spell. And now we are going to take, okay, so j would be the index returned from our binary search, and that would be, we'll call our binary search n-1, that is the size of portion, comma the target, which is the value of p. Now what are we going to do is, okay, we will create our pairs array where we will store our results. So now pairs dot push, we are going to push the value of n minus j. That would give the number of pairs for that spell, and then finally we are going to return our pairs array. Now let's try to run our code. So we know that for binary search, okay, there is some problem here. Okay, so what went wrong? Let's see. Since we are not using this anywhere, let's remove that. Okay, so we did not sort our portions array. That is a very big mistake because we are performing a binary search on that array, and without sorting and performing a binary search is a very big mistake because binary search can only be performed over a sorted array. So now let's run it. All right, let's submit it now. So binary search, we know that it can be executed in logarithmic time complexity, right? So since the portion length is n, so this would be O of log n, and we are iterating over each of the spell. That would be O of n m